Hello everyone, that's Mohammed Yaqub, and this is another video on the STM Nucleo tutorial series. And at this video, I'd like to show you how to use SPI on the Nucleo. Well, I assume if you search for SPI, I assume you know a little bit about it. You know that has got a serial clock provided by the master, has got a MUSI that goes from the master to the slave, and a MISO line which goes the other way around from slave to master, and a chip select for each independent slave. This video is meant to be a startup guide for people who want to learn how to use SPI on the Nucleo board. It will show you things like setting up the SPI interface on CubeMX and how to transmit and receive data via SPI. So in my demo today, I'm going to be using this NRF24 radio transceiver as my SPI slave device. So I'm going to write and read from this device through SPI. Alright, so let's get started and set up a project in CubeMX. And on CubeMX, click on New Project and select the right board. So we're using the Nucleo. So go to Board Selector. It's the Nucleo 64 pins one, and the MCU series is F4, and it's the F401RE. And this is the board pinout by default. I'm going to clear it up and set it up manually. So go to Pinout, Clear Pinout, hit Yes. I want to enable the onboard LED first. Might come useful. And then I need to enable one of the SPI lines. So I'll enable SPI 1, but I'll take the output. So you notice this one enabled PA6, PA7 and PB3. Normally it would enable PA5, but because I use PA5 for LED, so it used the alternate bin. What I want to also do is that I want to set those to the alternate pins so that I can take them easily on the Arduino connector. So if I set them with the alternate, they will become BB3, 4 and 5. I can take them from here. So that's what I'm going to do. When you click on any of them with the control, it will show you the alternate in blue. So it was BB4, SPI1 MISO, PA7 alternate is BB5, set up to SPI MUSI. And that's all. So I enable SPI line. And this enable SPI on the alternate pins. So I can take my output on BB3, 4 and 5, B3 being the clock, B4 being the master input slave output, and BB5 being the MUSI line. Now I also need to enable a chip select line. I'm going to enable it on D8 on the Arduino connector, which is PA9 on the STM. So PA9 is this one. I'm going to set it to GPIO output. And just a little comment, I'm sure you know that chip select line on the SPI, you bring it low to activate the device, and you bring it high again to deactivate the device. So whenever we want to read or write to the slave device, we will set this one to low, do the read or write operation, and then bring it high again. Okay. Now let's go to the configuration and see if there's anything we can change on the SPI. I'm not going to change anything in here, but I'm just going to lower the baud rate a bit. So I'm going to put a prescaler of 32. So whatever clock we have will be divided by 32. So, and click OK. Now we're ready to generate the code. So click on Generate Source Code icon. Give the project a name. I'm going to call it SPI Video. Select a location to store your files in, and select the right IDE. So MDK ARMv5 in my case, and hit OK. And now once the source code is generated, click on Open Project, and this will take you to your IDE. And on Keil, the first thing we need to do is to open the main, and we need to set the chip select line high to start off with, so that the slave will be deactivated. And we do that with the HAL GPIO write function. And I know my chip select pin is on port A, and it's pin number 9. It's PA9, and I need to set this one high to start off with. I'll put a little delay of 10 milliseconds perhaps. So this will guarantee that our external device, the NRF, is deactivated at the start. And now let me show you how to read data via SPI. So read data. As a general rule, to read data via SPI, you first need to send the register address to open communication with that address, and then followed by a read operation. For this specific device, the NRF, according to the datasheet, it says if I want to read, I have to first send a read command, which is just the register address I want to read from. And I want to read from perhaps register 05, the RF channel frequency. And this one by default is set to 2, so 02. It should read 02 by default after reset. So to read, step 1 is to put the chip select low. And so we use the same function as this, but instead of set we do reset to bring it low, and this will activate the SPI device. And then the next thing I need to do is to transmit the register address, and we use SPI transmit function for that. So HAL SPI transmit, you click control space to see the auto typing, so transmit SPI transmit. And this function takes a few parameters. The first one is the SPI handle type div, which is SPI1 defined by CubeMX and given that name. The second parameter is an array of the data you want to send, then the size. So I need to define an array. I'll define it globally so that I can see it when I go to debugging window. It's an unsigned 8-bit array. I'm going to call it SPI data. I'll give it a size of 2 elements, and I need to pass it to this function after I set it. So I just want to send a single data byte, which is the register address. I want to read from register 05. So now I need to pass this to the function. The size is 1 byte, and the last parameter is a timeout. 10 milliseconds should be okay. Next, I need to follow this by a read operation so that I will read the register content. And to do this, I need to do HAL SPI receive instead. And the receive function takes exactly similar parameters, except the SPI data will be where you want to store the return data in. And I want to store them in index number 1, not index 0. So I would have to make this a pointer to that location. I'm receiving 1 byte, timeout of 10 milliseconds. And then I need to terminate this by putting the chip select high again to deactivate it. So instead of reset, it's going to be set. Okay, now we're ready to compile the code and test it. Compiled okay with no errors. Now let me load it to the board, and we're going to go to debugging mode to see the value. And on debugging mode, I need to add this array to the watch memory so that I can see the variable in real time. I'll expand this up, remove the hex display, I'll expand this. And I expect my read data to be in index number 1. So let me run the code. Okay, superb. I get 2 just as I expected. I can put the hex display back actually. 02, this is what I expect, because by default this one all zeros except bit field number 1. So this corresponds to 2. Now let me show you how to write data via SPI. And according to the data sheet of this NRF device, to write to a certain register, we first have to send a write command, which is similar to the read command, except we have to set this bit field to 1. Now, from majority of the SPI devices I work with, this is not required, but for this specific device, it is required. So you always have to check with your device datasheet. So let me do this. So step 1 is, so I'm doing write operation, and I'm going to write to register 0x05, the RF similar register, the RF frequency. Step 1 is the same. I have to put this chip select line low, and then step 2 is very similar as well, except I have to transmit the register address with that bit field being high, which is this one, correspond to doing an OR with 0x20, because this one 0x20 is just the second bit on the upper 4 bits, so this is equivalent to this. And then followed by the data I want to write to that register. So I'm sending 2 bytes here, and I want to write something like 67. Just experiment, you can write any values. And now this will be 2 bytes starting from the startup address. So this will send the register with this bit field being high, and then followed by the data. And the device, the NRF, will understand that we're trying to write 67 in hex to this register. And now I just need to terminate it by bringing the chip select line high again. And to verify that this was written successfully, I'm going to do another read operation, reading from the same register again after I do the write. So I just copied this down here. So after I write to register 05, this will read register 05 again. Sorry, this needs to be 2 bytes because I'm sending register followed by data. And now I'm ready to compile the code. So let me compile it, and we'll load it to the board, and we'll get back to the debugging window. And on the debugging window, our array is already added to the watch memory from previous one. I'm going to add some breakpoints. After I do the first read operation, I'll put a breakpoint here. And after I write, I'll put a breakpoint, and then I'll read the register. So let me start. The first read operation got me auto, just like what I expect, because the register is auto by default. And then I do my write operation, and then I read, and I get 67. So the write operation was successful because I can read 67 back. Okay, so I've just shown you how to use SPI on the Nucleo board. That's all for today, and as always, if you like this video and want to see more videos like this, don't forget to like and subscribe. Thanks, and I'll see you next time. Bye bye.